Hello everyone, this is Professor Coppola, and I want to do this short video for you to show you a shortcut to determine m and n in the rate law. I did show you the ratio method, but this is also a shortcut and you'll get the same answer for the exponents m and n. Okay, so here's our rate law. R is equal to K times the concentration of A raised to the power M times the concentration of B raised to the power N. Now, if the concentration changes, let's say it could be A or B, but let's just focus on A. If the concentration changes and the rate does not change, then the exponent M or N equals 0. So let's look at an example. We'll just look at concentration of A. So it goes from 1 molar to 2 molar, but the rate stays at 1 molar per second in both trials. Anytime the rate doesn't change, M is equal to 0. And again, our ratio method would also give you the same thing, and the same thing would be true for B. Now remember, when you want to find, for example, the concentration of B, when A and B concentrations are given in the trials, you have to choose the lines where the other one, A, doesn't change. Okay? Now, if the concentration doubles or triples, etc., that is multiplied by 2 or multiplied by 3, whatever the factor might be, and the rate changes by the same factor, i.e. it doubles or triples, multiplied by the same factor, then the exponent m or n equals 1. So let's just look at A, and the same thing would apply for B. So here's a concentration of A. The concentration of A is being multiplied by a factor of 2, so it's doubling. 1 times 2 is 2. It's doubling. 2 times 2 is 4. It's doubling. 2 times 4 is 8. So if each of these is doubled, multiplied by 2, and the same thing is true of the rate. The rate doubles, it's multiplied by 2. It doubles again here, multiplied by 2. Doubles again here, multiplied by 2. If the number you're multiplying these by, in each case, is the same as the number you're multiplying these by, m is equal to 1. In other words, if this doubles and this doubles, as you can see here in each line of the experiment, then m is 1. Let's say if the factor was 3. So each of these is multiplied by 3, and you find that each of these is also multiplied by 3, m is equal to 1. Or you could say, notice that each of these triple, and the rate also triples, multiplied by 3. If that's the case, they both are multiplied by the same factor, increased by the same factor, then m is equal to 1. And the same thing would be true for B. Now remember, you should also check with the ratio method, and you'll see that you're going to get the same answer. And one more situation. If the concentration, let's say, doubles or triples or is multiplied by some factor, and the rate is the square of that, so if the concentration doubled and the rate increases by doubled square, or if the rate triples, if the concentration triples and the rate changes by a factor of triple squared, then the exponent of m or n is equal to 2. In other words, whatever factor of increase here, the square of that factor, if you find that in the rate, it's m is equal to 2. All right, so let's look here. So we're multiplying everything here by 2. In other words, each of these is doubled. And if you find that the rate is multiplied by 2 squared, here, what's 2 squared? 4. 4 times 1 is 4. 4 times 4 is 16. Then m is equal to 2. Here's another example. Let's say concentration of A is 1, 3, and 9. Notice that the factor here is 3. Each is multiplied by 3. And if the rate changes by a factor of 3 squared, 3 squared is 9. 9 times 1 is 9. 9 times 9 is 81. If you notice that, then m is equal to 2. So once again, whatever factor of increase you have here, in this case it triples, or the factor is 3, you're multiplying this by 3, multiplying that by 3, and then you get 3 times 3 is 9. If then the factor of increase is 3 squared, as we see here, 3 squared is 9, then m is equal to 2. Okay, so that's just a shortcut, and I hope this was helpful. This is Professor Coppola signing off.